Today's lesson is about proportional reasoning. In the lesson, you're going to learn what the word proportion means. You're going to determine whether two ratios are proportional. You're going to display different types of proportions in graphs and tables and on number lines. And then you're also going to use proportions to calculate unit rates or averages. Let's get started. First things first, what is a proportion? Well, a proportion is an equation that shows that two ratios are equivalent, which also means equal. So, for example, here are some proportions. There's equal signs between all of them, which means they are equations. And the first one here, 1 over 2 or 1 to 2 is equal to 2 to 4. That's a simple one that most of you guys, hopefully when you saw it, figured out immediately. A second example of a proportion is 50 miles in 1 hour is equal to 300 miles in 6 hours. If the 50 miles in 1 hour was a constant rate, in 6 hours someone could travel 300 miles. The third one here, a different type of proportion with money. This shows that if 8 items cost $6, you could get 1 item for 75 cents. So some of you may already know how to calculate that. If not, we're going to teach you how to do that today. So, first thing, we're going to look at two different methods to determine whether two ratios are proportional. So here you're given two ratios, 12 to 18 and 8 to 12, and we're going to simplify both of those ratios to see if they're proportional. If, when they're simplified, they look the same or are equal, that means they are proportional. So let's take the two ratios. We have 12 to 18 here. We have 8 to 12 down there. Let's simplify the top one first. Think about common factors for 12 and 18. There's a few of them. The greatest common factor, though, is 6. So if we divide both of those numbers by 6, the numerator and denominator, the simplified ratio is 2 to 3. Now let's simplify 8 to 12. There's a couple different numbers you could use to divide 8 and 12. The largest of those is 4. If we do 8 divided by 4 and 12 divided by 4, we get our simplified ratio as 2 to 3. So notice that those two ratios look identical now. If they are identical, that means they're equal, obviously. And if they're equal, that means they are also proportional. So 8 to 12 is proportional to 12 to 18. So just like we were saying earlier with the 50 miles in 1 hour and 300 miles in 6 hours, it's kind of like a constant or proportional increase that you can see with ratios when they're proportional. All right? So method 1 again is simplifying your ratios. So let's practice that real quick. Hit pause. Simplify the two ratios in question 1. See if they're equal. If they are, that means they're proportional. Simplify the two ratios in question 2 and do the same thing. See if they're proportional. Okay, hit pause, and then when you're done, you can hit play and see how you did. All right, here's the work for the two sets of questions, or the two questions here. In question 1, the ratio 10 to 15 simplifies to 2 to 3. The ratio 6 to 9 also simplifies to 2 to 3. That means those two ratios are proportional. In question 2, though, if you simplify, 7 to 28 simplifies to 1/4. 6 to 16 simplifies to 3/8 or 3 to 8. So you can notice they don't look identical, which means they are not proportional. Let's move on to method 2, cross products. You guys have been using this for most of the school year to determine greater than, less than values for fractions and ratios. Now we can use it to determine proportionality. So 12 to 18 and 8 to 12, same two ratios that we started with in the first example. So we already know they're proportional. Let's do our cross products, or butterfly method as some of you know it, to see if they're proportional. Let's start off with multiplying 12 by 12. So 12 times 12 is equal to 144. The other diagonal, 8 times 18, if we multiply 8 times 18, we also get, guess what, 144. So when you use cross products and the two products are equal, the 144 and the 144, that means that the two ratios that you have in the equation here are proportional. So again, just like when we simplified, 8 to 12 and 12 to 18 are proportional ratios or fractions. So use your cross products here to determine proportionality. So hit pause, take a few minutes to do the multiplying and see if they're proportional, and then you can check your work. Okay, here we go with this one. For question 1, you can tell here that the 8 times 5 and the 13 times 3 are not equal. So that set of fractions or ratios is not proportional. In question 2, 9 times 4 and 6 times 6 both equal 36, so that means those two ratios are proportional. So that's how we can determine proportionality. Now let's use tables to show proportional ratios. So we're going to set up a table here based on the example. The example tells you that the ratio of boys to girls in a classroom is 1 to 2. That doesn't mean there's one boy and two girls in a classroom. There could be, but it doesn't mean that. It just means the ratio is 1 to 2. So it could be a variety of different total of students in the classroom. As long as the ratio is 1 to 2, it's going to match and be proportional to the ratio given here. So let's create an XY table to show the possible number of boys to girls in the class. So here's my table. I'm going to start by labeling one of the columns X and one of the columns Y. So boys can be the X column, girls can be the Y column. And I'm going to start filling in my numbers. So the ratio that you're given usually goes in the first set of boxes. So the original ratio will go right here. So I'm going to put in my ratio of 1 boy to 2 girls. And I'm going to use that original ratio to find new ratios. So one way to find a second ratio is to take each of my original values and multiply it by a whole number. The smallest one to get a new number is 2. If I multiply them by 1, I'm going to get the same numbers here, 1 and 2. But if I multiply this by 2 and this by 2, it's going to give me a new ratio that's proportional to the original ratio. So I can multiply 1 times 2 to get 2, and 2 times 2 to get 4. So the number of students that could be in this classroom could be 2 boys and 4 girls. If I take my original ratio and multiply each of the red numbers by 3, 1 times 3 gives me 3. 2 times 3 gives me 6. So the number of students that could be in the room is 3 boys and 6 girls. That ratio is proportional to the original. Now let's do one more. We'll multiply each of the red numbers by 4. 1 times 4 gives me 4. 2 times 4 gives me 8. So there could be 4 boys and 8 girls in the room. So you can see that when someone tells you the ratio of boys to girls in a classroom is 1 to 2, they're not saying that there has to be 1 boy and there has to be 2 girls in the room. It can be any pair of numbers that are proportional to 1 to 2. We could keep going if we wanted to. I don't have any more boxes here, so I'm not going to, but you could multiply the original ratio by 5 or 6 or 7, whatever you want to. Okay? One other thing about ratio tables, this one has the boys and girls at the top and has the numbers going down. You'll also see ratio tables that run sideways instead of up and down. So there's not an example in the notes here, but you'll see that in the homework and probably in various places in class. Okay? So each ratio is written in the table is proportional to the others. That's what I was saying before. You can use the ratio table to create different things. So you can see they're all equal here. We're going to use these equal ratios, these proportional ratios, to show other displays. Okay? So one other thing to keep in mind. What we did here is multiply to get our numbers from the original ratio. We multiply by 2, by 3, and by 4. But take a look at the ratios that we have here. If you take the x value here and multiply it by 2, that tells you how many girls there are. 1 times 2 is 2. That works all the way through. If you take the first number in each ratio and multiply it by 2, 2 times 2 is 4. 3 times 2 is 6. And 4 times 2 is 8. There's a name for that number that you can multiply the first value or the x value by to get the y value or the second value. So that number has a name. Like I said, it's an important name to know because you're going to be asked about it, and it's going to be something that comes up in math class this year and in future years. And that number is called a constant of proportionality. Constant, remember, when we did expressions, is a number that doesn't change. This 2 doesn't change. It's always going to be times 2 times 2 times 2 times 2 in this ratio. When you're given a different ratio, it might be a different number, but it's going to be the same throughout the table. So it's a constant of proportionality. It shows proportions, proportional numbers, by using a constant number to multiply by. Okay? So that's definitely something you're going to be asked about throughout this unit. All right? So let's take our proportions and put them on a graph. This is one of the visual representations that I told you could use. And that's why I was kind of saying that the boys are the x values and the girls are the y values. because remember that a coordinate plane has an x coordinate and a y coordinate. We're going to use that idea to put this on a graph. All right? So I made my graph here. I put the boys on the x-axis because that was the x value. I put my girls on the y-axis because that's the y values. And I numbered my grid so that I have room to put all of my numbers on there. So let's start by plotting the first proportion here, the first ratio, 1 to 2. Remember that the x value is sideways, the y value is up, so I'm going to go to the right 1 and up 2. The second ratio, 2 to 4, I'm going to go to the right 2 and up 4. The third one, I'm going to go to the right 3 and up 6. And then the last ratio, 4 to 8, I'm going to go to the right 4 and up 8. So a couple things to notice here. You can see that they're creating a pattern, and that the pattern is going to be a straight line if I put an arrow through that. So I'm going to put an arrow through here and see that it makes a straight line. So not only do proportions make a straight line on a coordinate plane, but they also always pass through the point 0, 0, or the origin. This would be the origin right here. You can't see quadrant 2, quadrant 3, and quadrant 4. We're only working in quadrant 1. But this is still the origin right here. So it's going to pass through 0, 0. Okay? So again, here's the notes of what I just said, the rundown. Proportional ratios will create a straight line, like I said, that runs through the origin on a coordinate plane. Okay? So another way to show proportional ratio tables is on a double number line. So what we're going to do here is take the ratios and show them using two number lines, and you're going to be able to identify the ratio in those number lines. So let's start by drawing a number line. Okay? This one's going to be for the boys. So if I start at 0, well, there's one for the girls. If I start at 0 on both of them, I'm going to number the boys by 1s and the girls by 1s. And what you'll notice is that original ratio 1 to 2 is where those two numbers line up. So the number of boys, 1, lines up with 2 girls. I'm going to finish filling in the boys number line and label it. And I'm going to finish filling in the girls number line and labeling it. Okay? So you're just going to draw two number lines or identify two number lines. And if I ask you what the ratio of boys to girls is based on these number lines, you can look right here and you can see it's proportional because every time the girls goes up by 2, the boys goes up by 1. So there's your constant of proportionality again. It's times 2 to go from boys to girls. So the original ratio you were given is right here. The 1 and the 2 line up. So there is 1 boy for every 2 girls. Most of the time you're going to be asked to look at number lines and identify either the constant of proportionality or whether they're proportional at all, if it's showing a proportion, and maybe a unit rate, which you're going to learn about in a minute. But that's the basics. You're going to have two number lines, one for each item in your ratio, and you can use a table of proportional ratios to create a double number line. Okay? Last thing for the lesson today, unit rates. What is a unit rate? A unit rate is when you compare two quantities to make a ratio, but the second quantity is 1. So you guys see this a lot in grocery stores or in other places where multiple items are used. You also see it when you talk about distances. So for example, miles per hour in a car is a unit rate. So we're going to talk about how to create or how to find those today. All right. So here's some examples of unit rate. Something could cost $5.99 for 1 pound. You can buy 4 candy bars for $1. You can drive 65 miles per hour, or that could also be said as 65 miles in 1 hour. Or someone can run 11 meters in 1 second or per second. Those are all unit rates. It's how much something costs, how fast something happens in 1 unit of whatever the bottom number is on your ratio. Okay? So here's how we find unit rates. You can take a ratio and divide both parts of that ratio by the denominator. Because when you do that, the denominator will turn into 1, and then you will have a unit rate. So here's an example. Billy can answer 90 times table problems in 3 minutes. What is his average problems per minute? When you see problems per minute, that's asking you for an average or a unit rate. So let's start by writing a ratio. What he can do is he can write, or he can solve 90 problems in 3 minutes. That's a rate. It's a ratio, but you call it a rate because the numbers have labels after them. He can do 90 problems in 3 minutes. Now let's find a unit rate. A unit rate is when we divide both of these numbers by whatever the denominator is. If the denominator is 3, that's what we're dividing by. We're dividing it by 3. And we're also dividing the numerator by 3. Okay? So when we do that, we're left with 30 problems in 1 minute. That is his average number of problems per minute. He may answer 31 in 1 minute and 29 in another, but his average, or the unit rate that he solves problems at, is 30 problems for 1 minute, or 30 problems per minute. That is the new ratio that we found, and that is a unit rate. Okay? So again, the rule here is whatever the bottom number is, just divide by it. You're not always going to get a whole number on the top when you do that. Okay, so let's take a look at a second example. Millie can answer 65 times tables problems in 2 minutes. What is her average problems per minute? So if we start with writing our rate like we did last time, her rate is 65 problems in 2 minutes. Here, since we want to make a unit rate, we're going to divide by the bottom number, which is 2. If we divide by the bottom number of the denominator, which is 2, the denominator will turn into 1 minute, but you guys should already be able to figure out that when you divide an odd number by 2, it's not going to be a whole number. It's going to have a 0.5 after it. So when we do our division here, it's 32.5 problems in 1 minute. That is her average, or that is the unit rate for the number of problems that she can answer in 1 minute. All right? So let's try a couple practice problems out. Try to answer these, find the unit rate for each one, and then when you do, you can hit play again and see how you did. All right, here's your first, or your 2 answers. Jack can type 123 words in 3 minutes. That is your rate. To find the unit rate, you divide by the denominator, which is 3. So on average, or the unit rate, is that he can type 41 words in 1 minute. For question 2, it says Sarah is competing in a 500-mile car race. You should have figured out that 500 is not a number that you need to use to solve this problem. That is irrelevant information. What's relevant is that the first 2 hours of the race, she traveled 357 miles. What is her average speed? That means her average speed would be a miles per hour, or miles in an hour. So the original rate is 357 miles in 2 hours. If you divide that by 2, which is the denominator, you can calculate that she's traveling a unit rate of 178.5 miles for 1 hour, or per hour. All right? So that's the lesson for today. Go back and rewatch if you need to. Use this when you need to, and I'll see you next time.